Good afternoon, everyone. Good afternoon, everyone. Let's begin with today's class. And today we are going to talk about one of the interesting topic of biochemistry, that is metabolism of xenobiotics. And that we'll be doing in two phases. And as we say in the beginning, that let's crack NEET PG together. So the topic of today is metabolism of xenobiotics. Metabolism of xenobiotics. Before beginning with today's topic, let us have a small introduction about Unacademy. Unacademy is one of the India's largest platform for the preparation of NEET PG examination, and you will get the best educators all over India on Unacademy. So these are some of the best educators all over India, with the help of whom you can prepare for the examination and qualify the NEET PG examination. Then there are special classes conducted by Unacademy, and in these special classes you can ask your doubts directly with your faculty member. They'll be very much willing to answer your doubts and queries. So special classes can be highly beneficial in preparation of examination and solving your doubts. Then there are test series, and as I always say, it is very important to know the PYQs and MCQs and to know the pattern of the examination if you are preparing for any examination. That is also possible in Academy. There are free mock tests and weekly tests so that you can evaluate yourself that how much you have learned so far. And these weekly tests and free mock tests, these are also on the basis of the topics which you have read. So you can just read one topic and attempt the test for the particular topic. So test series can be highly beneficial. Then this is one of the easiest way for the preparation of the NEET PG examination because there will be flexibility of the schedule. You won't have to make any change in your schedule. Just you can enroll for the class and anytime you can watch the video. If you're out of town or anything, then there is lots of flexibility in this type of module. Then language can be of your choice. Like there are many educators who teach in the regional languages as well. So language can be of your choice. Then unlimited practice of quizzes and what recorded videos can be done. Once the quiz has been live, you can just go back and take the quiz as many number of times as you want to when you have prepared the topic completely, and you can even watch the recorded videos as many number of times as you want to. So this is one of the most easiest and feasible way of preparation. Then you won't feel anything different from a normal classroom like feeling because you can chat with your educator. Then there will be interactive polls. You will have to answer the questions which your faculty member they are asking you, and in each and every option will be explained by them. The interactive poll is a very interesting. So yeah, there was some problem in internet. Let us begin again. That is xenobiotic metabolism. Xenobiotic metabolism, right? So this xenobiotic metabolism, it has got two more terms, that is biotransformation, and it is also called as detoxification. Biotransformation and detoxification. So what is this biotransformation and what is detoxification? So yes, they are in in some terms they are quite similar, but if we are talking about specifically biotransformation, so the term itself is telling us about that there is some transformation going on. So whenever a biochemical reaction is going on and there occurs a chemical change, like first chemical is getting converted into second chemical, it is called as biotransformation. So let us see this biotransformation. It's a kind of biochemical reaction. Biochemical reaction, and this biochemical reaction which occurs in body, and what happens in this reaction is chemical 1 gets converted into chemical 2, and this chemical 1 is 100% toxic, no doubt, and the chemical 2 which is produced from chemical 1, it may be toxic or it may be non-toxic or it may be less toxic. So the chemical 1 is changed into chemical 2. So the chemical 2 can be toxic, non-toxic, or it can be less toxic. Now, if we are specifically talking about individual term, let us see this detoxification. So we'll be starting our class from detoxification. That what is this detoxification? Detoxification. So as the term itself is saying that there will be conversion of a toxic compound into non-toxic or less toxic compound. It is called as detoxification. So how will we define it? Conversion of a toxic compound into non-toxic or less toxic compound in body, which is now water soluble. What does this water soluble means? That it is in the excretable form. Excretable form, right? So this is detoxification, conversion of a toxic compound into non-toxic or it may be less toxic. So this is about detoxification, right? If the compound it is converted into more toxic compound, here we are saying it can be less toxic or it can be non-toxic. What if it is getting converted into a high toxic compound? Then the process is called as intoxication. Intoxication. What happens in this conversion of a toxic compound, conversion of toxic compound into more toxic compound, conversion of less toxic compound into more toxic compound comes under intoxication. So one of the example of this is conversion of methanol into formic acid. Conversion of methanol into formic acid. So this is intoxication. So this is about the terms which we are talking about. What is biotransformation, conversion of a chemical into another thing, then toxification, and then intoxication. So these are the terms which we have just discussed. Now let us move towards xenobiotics. If we are saying xenobiotics and we are saying they are toxic, so what are the compounds which are actually included in xenobiotics. What are those things which comes under xenobiotics, and which chemicals will be called as xenobiotics? Those students who are attending the class, they can write in the chat box if they can hear me properly. Okay. They can hear me properly, they can write in the comment box. So what is xenobiotic? Xenobiotic is a foreign compound which needs to be detoxified. It's a foreign compound, foreign compound which needs detoxification. Xenobiotic is a foreign compound which needs detoxification. Now, what are the things which are included? The things which are included in xenobiotics are additives, they are adulterants, then bilirubin, histamine, putrescin, then cadaverine, tyramine, tryptamine. These are some of the xenobiotics. So let us talk a little bit about them. That this bilirubin, it is a toxic compound which is produced in body. Histamine, it is a toxic compound which is produced in case of bacterial action. Right? So additives, adulterants, bilirubin, histamine, putrescin, cadaverine, tyramine, and tryptamine. Some are some of the xenobiotics. Some other xenobiotics includes cosmetics, drugs, then environmental pollutants and pesticides. And there are some more also, etc. So remember at least these xenobiotics which are present in our body, and they are actually foreign to our body, so it needs to be detoxified. So xenobiotics are foreign in nature, and they are additives, adulterants, bilirubin, histamine, putrescin, cadaverine, tyramine, tryptamine, cosmetics, drugs, environmental pollutants and pesticides, right? So let's move further, that how are they detoxified? If we are saying that yes, they will be detoxified, so what is the way in which they will be detoxified? So metabolism of xenobiotics, it occurs in two phases. Metabolism occurs in two phases. Now we'll be discussing about both of the phases. So first of all, phase 1. Phase 1. What happens in phase 1? Like some of the xenobiotics, they can be converted into non-toxic compounds in phase 1 only, and some of them they need phase 1 as well as phase 2. So for some of the compounds, the conversion of toxic into completely non-toxic occurs in phase 1, and for some of them toxic is converted into lesser toxic in phase 1. So right, phase 1, toxic getting converted into non-toxic, water soluble, and some of them toxic into less toxic, and this less toxic will be again water soluble, right? So the one which will be completely metabolized by phase 1 will be the one in which toxic is getting converted into non-toxic, and the one which needs phase 1 as well as phase 2, that will be toxic into less toxic. This will require phase 1 as well as phase 2, toxic into less toxic, right? So for some of them to become completely intoxic, they require phase 2 as well. So some requires phase 1 and phase 2 for becoming completely intoxic and water soluble, right? So this is the basic concept. Now we will be dealing about the phase 1 in detail and then phase 2. So we have understood the introduction, we have understood how it what everything is. Now we are let's moving towards the actual process. So phase 1. Now what happens in phase 1 is the special group is added to the compound so that it becomes less toxic and water soluble. So in phase 1, a group is added to compound so it becomes less toxic and water soluble. This is the first thing which occurs in phase 1. And this phase 1 is itself made up of three main reactions. Three main reactions. So what are those three main reactions? First one is oxidation or hydroxylation. Phase 2 of second reaction in the same thing. The first one is oxidation, second one is reduction, and third one is hydrolysis, right? So phase 1 itself is made up of three steps. Phase 1 is made up of three steps: oxidation, which is also hydroxylation, reduction, and hydrolysis. So let us move towards oxidation, the first one. Oxidation. Now what happens in oxidation? There will be an addition of cytochrome P450. Remember this very well. Addition of cytochrome P450. Now, what type of oxidation reaction it is? Let us make a list. It's a mixed action oxidase. Mixed action cytochrome P450. It's a mixed action oxidase. Then it is monooxygenase. Is a monooxygenase. Then it needs NADPH as coenzyme. Then it needs phosphatidylcholine for its action. Phosphatidylcholine for its action. Then there are so many forms of cytochrome P oxidase, that is around 20 to 200 forms of cytochrome P450 are present. Then it is present in microsomes of liver in high concentration. Then it absorbs at 450 nanometer. The maximum absorption it shows is at 450 nanometer when it is exposed to carbon monoxide, right? So the site of detoxification, if we are looking over here in this whole page, the site of detoxification is actually the liver, right? And the thing which performs is cytochrome P450. So it's a mixed action oxidase. Then it's a monooxygenase. It needs NADPH. It needs phosphatidylcholine. Then there are 20 to 200 different forms of cytochrome 450. They are present in microsomes of liver in high concentration, and when it is exposed to carbon monoxide, it shows absorption at 450 nanometer. Right? So the site of detoxification is liver. The site of detoxification is liver. Now let us move towards some of the examples. Hi Kushagr. Examples. So examples of oxidation. So we'll be seeing alcohol, aldehyde, amine, aromatic hydrocarbons, sulfur compounds, and drugs. Right? We'll be seeing the oxidation of these things. So first of all, in the list we have this alcohol. So alcohol, first alcohol, that is methanol, it will be converted into formic acid with the help of oxidation. Ethanol will be converted into acetic acid. Benzoyl alcohol will be converted into benzoic acid. Now, this example of conversion of benzoyl alcohol into benzoic acid will be further taking the steps from benzoic acid in phase 2 reaction. I told you some of them are completely detoxified in phase 1 and some needs phase 2 as well. So the example which we are going to deal in phase 2 as well from the phase 1 is conversion of benzoyl alcohol into benzoic acid. This will be further taken in the phase 2 reaction as well. So alcohol it changes into its respective acids. Now let us move towards next, that is aldehyde. Aldehyde. In aldehyde, benzaldehyde, benzaldehyde will be converted into benzoic acid. Chloral will be converted into PCA. And this is about our second step, that is aldehyde. Let's move towards the third, that is amines. And in amines also we are seeing aliphatic amines. Aliphatic amines. So what will happen in this, that aliphatic amines will be converted into aliphatic acids. Aliphatic acids plus urea. Right? Now, fourth, aniline. Aniline will get converted into aminophenol. Then fifth, aromatic hydrocarbons. Aromatic hydrocarbons will be converted in phenols, or betterly we can call as monohydroxy, dihydroxy, trihydroxy versions of aromatic hydrocarbons such as benzene. So it will be converted into phenols and monohydroxy, dihydroxy and trihydroxy. Right? So in this page we have seen about aldehyde, that is how aldehyde is converted into its respective acids. Aliphatic amines, they'll be converted into aliphatic acids and urea as well, because the amine group it will be given to urea. Then aniline, it will be converted into aminophenol, An aromatic hydrocarbon benzene, it will be hydrocarbon, that is benzene, it will be converted into phenols, that is monohydroxy, dihydroxy or trihydroxyphenol. Let's move towards the next, that is sulfur compounds. Sulfur compounds. Sulfur compounds, they'll be converted into sulfuric acid. Sulfur compounds, they'll be converted into sulfuric acids. And then let us talk about drugs. The drugs, they'll be converted into hydroxy version of the drugs. So one of the example is mepro. Meprobamate will be converted into hydroxy meprobamate. So hydroxy version of the drug, whichever is entering into detoxification reaction, it's hydroxy version, right? And now when they are converted into non-toxic or completely water soluble forms, then they'll be completely excreted out into the urine. And in some of the cases, when they are converted into less toxic ones, they'll be entering into the phase 2 reaction, right? So this phase 2 reaction, it is actually a kind of conjugation reaction. The phase 2 reaction is a kind of conjugation reaction. But first of all, let us talk about the reduction and hydrolysis, because as I told you that it is consisting of three steps, that is hydrolysis or oxidation, reduction, and lastly hydrolysis. So first step we have seen, that is oxidation. Now we are moving towards reduction, right? So what happens in reduction, the compounds, they'll be converted into its respective acids only, and it is very much important in nitro compounds. It is quite important in terms of nitro compounds. Nitro compounds. So the short form to remember this can be PNC. P stands for picric acid, N stands for nitrophenol, C stands for chloral. Picric acid will get converted into picramic acid. Nitrophenol will get converted into aminophenol, and chloral will get converted into trichloroethanol. So it is very much important for nitro compounds. It means that this step, nitrophenol into aminophenol, this is done with the help of reduction reaction, right? So we have seen the reduction also. The first one was oxidation, second one is reduction, the third one is hydrolysis. The third one is hydrolysis. So what happens in hydrolysis is the bigger compounds, they'll be converted into smaller ones. Like if it is XY, will be converted into X and Y. And one of it will contain OH of water and one of it will contain the H of water. So hydrolysis reaction. So the drugs which are detoxified with the help of hydrolysis, let us just outline the names of the drugs which are detoxified with hydrolysis reaction. So drugs detoxified by hydrolysis reaction. So what are the names? First one is aspirin. So first of all, let us write the names of the drugs. Atropine, procaine, xylocan. So they are converted by the help of hydrolysis, aspirin will get converted into salicylate and acetic acid. Salicylate plus acetic acid. Atropine will get converted into tropin plus tropic acid. I hope you people are understanding what I am trying to tell. The drugs which are detoxified by hydrolysis reaction, first aspirin, atropine, procan, and xylocan. Right? Procan and xylocan, they are used by anesthetist. Right? So these are the examples of the drugs which are actually detoxified by hydrolysis reaction, right? Then another thing, another example which is highly important according to the exam point of view, that is DFP. Its full form is diisopropyl chlorophosphate. Chlorophosphate, and it is a nerve gas. So nerve gas. So it is very important according to exam point of view. It was a famous PYQ as well. So nerve gas. So it is also detoxified by hydrolysis. Hydrolysis. Right? So diisopropyl chlorophosphate is detoxified in the phase 1 with the help of hydrolysis reaction, right? So this is all and everything about the phase 1. Let us move towards phase 2. As I told you, those compounds which cannot be completely detoxified in phase 1, they need to enter into phase 2. So let us move towards phase 2 and let us see how this phase 2 occurs. Okay, so phase 2 is a kind of conjugation reaction. Phase 2 is a conjugation step. So what happens is that foreign substance which is toxic in nature and the compounds which are produced in the body, they both will be joining and they will be giving rise to a less toxic compound which can be easily excreted out from the body. So what happens in conjugation or phase 2? Foreign substance, foreign substance which is toxic will combine with compounds produced in our body, and then they will be converted into less toxic water soluble compounds, right? And then it will be excreted out, and then it will be excreted out from the body. So this is the general outline of phase 2. We need to go in detail. So phase 2 is a kind of conjugation reaction in which the foreign toxic material is joined with the compounds which are formed in the body, and then they'll be converted into less toxic one, and then they will be excreted out from the body, right? This is the simple outline. Now we are going to talk about this conjugation in further steps. So let us see in how many steps we are going to see it. We'll be seeing 4 G's, then we'll be seeing S, then we'll be seeing A, then we'll be seeing M, and then we'll be seeing thiosulfate reaction. So G will be seeing, so S is for sulfur, A is for acetylation, M is for methylation, and SH is for the thiosulfate reactions, right? So we will be just talking about each and every reaction in detail. So let us see the G's. The G's. The first G. The first G is for glucuronic acid. Glucuronic acid, right? So glucuronic acid, its active form is UDP, glucuronic acid. This is its active form. And it's an important xenobiotic which is detoxified by glucuronic acid conjugation include. So the things which are detoxified by glucuronic acid, we are going to see the names of the things which are detoxified by this, and its active form is UDP, glucuronic acid. So the names of the things which are detoxified by glucuronic acid, let us write the key BSP. B is for bilirubin, S is for steroids, P is for phenols. We'll be seeing that how the bilirubin is actually detoxified by glucuronic acid. The first G is for the addition of glucuronic acid of our own body. So it will go like this. Bilirubin will combine with UDP, glucuronic acid, and it will be getting converted into bilirubin monoglucuronide, and which will be further changing into bilirubin diglucuronide. Okay, and this bilirubin diglucuronide is a water soluble compound. It is water soluble. So if it is water soluble, it means it will be excreted out in urine, right? And the thing, this bilirubin diglucuronide is also called as, the another name given to this thing, bilirubin diglucuronide, is also called as conjugated bilirubin. Is also called as conjugated bilirubin. So remember this, there was a PYQ on this. Remember this thing. So how this bilirubin is excreted out in the body? This ways, with the help of glucuronic acid, or more precisely saying that UDP, glucuronic acid, because that is the active form of glucuronic acid. Understanding? And the things which you need to remember which are detoxified by glucuronic acid is bilirubin, steroids and phenols. Okay, so this was the first G. Let's move ahead in this. That is the second G, that is glycine. Right? So glycine, it is also important in conjugation reaction. And how does this occurs is, glycine will react with benzoic acid. I told you that benzoic acid will be taken up further in the phase 2 reaction from the phase 1 reaction. It is not that it is taking up the reaction over here. We have seen about it in the phase 1 also. So glycine plus benzoic acid will give puric acid. Puric acid, right? So this is also one of the kind of conjugation reaction in which glycine is conjugating with benzoic acid. Another example of detoxification with the help of glycine is glycine plus folic acid, which will give rise to glycoholic acid. Glycoholic acid. Right? So this is our second G, and we have to talk about 4G. So this is about glycine and how glycine is giving rise to hippuric acid, which is a water soluble one, and it will be excreted out in the body, and cholic acid will be combining with glycine and it will be giving rise to glycoholic acid, and which will be excreted out in the body. Right? So this was the second G. Let us talk about the third G. The third G is for glutathione. Glutathione. Right, now how this glutathione is actually performing the whole reaction, let us talk about its another name. Its another name is also gamma glutanyl cystenyl glycine. This is its another name, right? So it plays an important part in conjugation, and the things which are detoxified by this, the examples of things which are detoxified by glutathione are alkyl groups, then alkyl halides and alkenes, right? So glutathione, this is our third G, 3G, and its another name is gamma glutenyl cystenyl glycine. And the things which are detoxified by this are alkyl groups, alkyl halides and alkenes, right? So this was the second G. Let us move towards the fourth G, that is glutamine. This is our fourth G. So this glutamine, it will react with the phenyl acetate, and it will give rise to phenylacetylglutamine. Right? This is how glutamine is performing the detoxification reaction. That is our fourth G. So first G was glucuronic acid, second G was glycine, the third G was glutathione, and the fourth G is glutamine. And the next in the series is S, right? So let us talk about S. How the sulfur will be participating. So yes. So benzene requires phase 1 and phase 2. Two phases are required by benzene for its detoxification, right? This we have already seen, benzene and how. And then if we are talking about S, so in some of the cases when benzene is getting converted into phenol, it will be further getting converted into phenyl sulfate. Will be getting converted into phenyl sulfate, and then it will be excreted out in the body, right? So the sulfate is also called as sulfate conjugation. The process is also called as sulfate conjugation. Right? S is for sulfur, and the process is called as sulfate conjugation, right? So the donor of the sulfate group over here in this process is your PAPS. The donor of sulfate group is PAPS. What is the full form of PAPS? It is phosphoadenosyl phosphosulfate, and it's a very active sulfur donor. Very active sulfur donor, and its full form is phosphoadenosyl phosphosulfate, right? So what will happen in this type of reaction is that phenol will react with actually PAPs and give rise to phenyl sulfate. Right? This is how your S is justified. Then we have to see A, M and T. So I think just a second, we will have to take a slide. Just a second. Just wait for 2 seconds. Yeah. Okay. So we have seen about 4 G's, then we have seen about S. Now we need to know about the A. A stands for acetylation. So acetylation It will occur with the help of acetyl donors. Acetyl donors will give acetyl group and it will be conjugated with the toxic one. So acetyl donor in most of the cases is acetyl CoA. Acetyl CoA will donate its acetyl group. So now we have talked about A, and the donor of acetyl group is acetyl CoA. Now after A, we need to talk about M, and M is leading into methylation reaction. So this M, and we know which is the universal methyl group donor, as you can remember from our classes, which is the universal methyl group donor, that is SAM. So SAM stands for S adenosyl methionine. S adenosyl methionine is your universal methyl donor. So methylation will occur with the help of SAM. And the example for the detoxification with the help of methylation reaction is conversion of epinephrine into metanephrine. Conversion of epinephrine into metanephrine. Right? So we have seen about 4 G's. S, that is sulfate conjugation, then A, and then M, and lastly we need to know about T. We need to know about T, and T stands for thiosulfate conjugation. Thiosulfate conjugation. Now, what is required in thiosulfate conjugation is cyanide. Cyanide is required for thiosulfate conjugation, right? Cyanide will combine with sulfate and it is converted into excreted form. Required for cyanide detoxification. Thiosulfate conjugation is required for cyanide detoxification. So cyanide will combine with the sulfate and then it will be converted into a water soluble form, and then it will be excreted out, right? This is how the process of whole xenobiotic metabolism occurs, the process of xenobiotic metabolism. So let us have a very quick revision of whole process. So xenobiotic metabolism we were talking about. It is also called as biotransformation and it is also called as detoxification. So when we are talking specifically about biotransformation, it means conversion of one form into another form, and we are saying detoxification, it means conversion into less toxic form. So detoxification, conversion of a toxic compound into non-toxic or less toxic compound, and intoxication means conversion of a less toxic compound into a more toxic compound. Conversion of less toxic into more toxic one. This is intoxication. Now, let us talk about the what is xenobiotics and what are the examples. So, foreign compounds which needs detoxification before removal from the body are called as xenobiotics. The examples are listed over here. We have already discussed them. Then metabolism of xenobiotic, it occurs in two phases, that is phase 1 and phase 2. If a compound requires more than one step for its detoxification, it will enter into phase 2, right? And if it is non-water soluble in phase 1, it will need phase 2, right? So phase 1 and phase 2. Phase 1 itself is made up of 3 steps: oxidation, reduction and hydrolysis. In phase 1, a group will be added to make it less toxic and make it water soluble, right? So first of all, we have seen about oxidation. Oxidation occurs with the help of cytochrome P450 or cytochrome P oxidase 450, and it's a mixed action oxidase and it's a monooxygenase and it needs NADPH for as its coenzyme. It needs phosphatidylcholine for its action. And there are many forms of this cytochrome P40, that is its 20 to 200 forms are there. Then they are present in the microsomes of liver, and it is also uh, showing its absorption when exposed to carbon dioxide at 450 nanometer. Now, some of the examples we have discussed about oxidation, how alcohol is converted into its respective acid, how aldehyde is converted into its respective acid, aliphatic amines are converted into its respective aliphatic acid and urea, aniline, they are converted into aminophenols, and aromatic hydrocarbons such as benzene, they are converted into phenols. Then sulfur compounds, they are converted into sulfuric acid, and drugs, they are converted into its hydroxy form, such as meprobamate is converted into hydroxymepropamate. Then we were talking about reduction, and in reduction it is more important for the conversion of xenobiotic nitrogenous compounds into its lesser toxic ones. So reduction was for nitrophenol into aminophenol mostly, and hydrolysis means conversion of a bigger compound into its smaller one, and one of the smaller one will have OH and one of the smaller one will have H. Now the drugs which are detoxified by hydrolysis, they are aspirin, atropine, procan and xylocan, and the nerve gas, that is DFP, diisopropyl fluorophosphate, is also detoxified with the help of hydrolysis. Then phase 2 is also called as conjugation. Some of the foreign substance will combine with the compound produced from our body, and it will get converted into a less toxic water soluble compound, and then it will be excreted out from the body, right? So it is divided under these heads: 4G, SAM, SAM and SH. Or you can, in place of S, you can also write T. You can also write SH/T because it is for thiosulfate. So the 4Gs, the first G is for glucuronic acid. The first G is for glucuronic acid. The the second G is for glycine. The third G is for glutathione. The fourth G is for glutamine. S is for sulfate conjugation, and the sulfur donor is PAPS, that is phosphoadenosyl phosphosulfate. Then acetylation occurs, and the group for acetyl donor is acetyl-CoA, and methylation, it occurs with the help of SAM, which is the universal methyl donor, that is S-adenosyl methionine. And the example over here is conversion of epinephrine into metanephrine. And lastly, thiosulfate. For this, the sulfate group is transferred, and here we have seen the example of cyanide detoxification. Cyanide, it combines with sulfate, which is which then converts into a water soluble form, and then it is excreted out from the body. So this is how we have done our xenobiotic metabolism, and hope you have understood everything clearly and in detail. And if you have understood the things in detail, please like my video, it really motivates me. And subscribe our channel, that is Let's Crack NEET PG. Also hit the bell icon for getting all of the notification for the upcoming videos on our channel. Lastly, don't forget to use my referral code, that is FB01, for the plus subscription. And if you'll be using my referral code, that is FB01, you will be getting an additional 10% discount in the plus subscription. So this is it for today's class. We'll be meeting again tomorrow with some of the very interesting topic of biochemistry. Thank you very much for your patient listening, and come back tomorrow for some more lectures.